Hello, everyone. So this is a quick video about a telescope lab. This lab is a bit different than what it was before. The menu has changed from what you see here to what you will see in the software. So now they have updated the menu to something like this. Now it's almost the same settings, but now it's easier to do the lens. Okay, so you're gonna notice when I do the lens that it's a simple process in comparison to the one in the lab instructions. Okay, so pretty much the idea with this lab is to explore what happens when you have a plane mirror using a single ray. Basically, what you're doing here is you're exploring the law of reflection. And then you can explore the same with a curved mirror. The idea with this part is just to check the angles. So you can build, you can have a protractor there. Should be more like this, like that. And then you can bring it down here. You see the purple dots in there? Make sure they align here like that. There. You see, this is 0. This is not exactly 180 because my line is not horizontal, perfect horizontal. But still, you can still measure the angles that you can see that is basically the same. It's about 32 here, 33. And here is about, well, it's a bit different. Let's see if I can fix this a little bit. Let's put it at 0. Let's make this. I think that will work now. Let's do this again. Light source. Okay, so this is a plane mirror. Then let's choose the right angle here. I think that should work there. In the protractor. It's probably better like this. And then let's bring it here. There it is, 60, 60. So it takes some time to kind of get used to this. But don't worry, because this is just for you guys to check how the program works. The main part of the lab is to explore, or I'm sorry, is to build telescope ray diagrams. So you're gonna do for refractor and for the free reflectors, the Newtonian, the Coude, and the Casimir. So for that, which is probably what you are more interested to see me doing, you are going to use the lens. So in a spherical lens is going to be your objective. And you see these purple dots? You can enlarge them a little bit. That's the focal point of the lens. And you can play with this. You can use a beam of light. And they're all going to be focused there. So that's what you expect from the objective. With the eyepiece, sort of, right, with the secondary spherical lens, you're gonna do it here. So you can change the shape of this lens Ooh. Until you have something that you are more. Can probably change this as well. Let's see what happens. You see, sort of like that. That's what you want. There. Can move this a little bit. So you want to make it look like there is the light being refocused towards the eyepiece here, right? So there it is. That's a refractor telescope. Of course, it can be even better. You can change the refractive index, and that will make it look more, you know, more like it, more what you will expect from a refractor telescope. If you're not sure how they look, you can always go to Google and put a refractor telescope diagram, and it will show you how it should look. There, or there. Two lenses there, right? That's the idea behind the refractor telescope. Now let's take a look at your reflector telescope. So we can undo this. By the way, remember to take a screenshot of this because your submissions are basically your telescope diagrams. There is a tutorial that I made already that you're gonna find in Canvas, but I'm doing this as an extra video to help other students who may not have access to that. You want to start with a curved mirror for the Newtonian. This is a Newtonian telescope. So that's your primary mirror. And you may want to do it first like this. Then you want to use the beam, or let's use a single ray first. Oh, what happened here? It's a telescope, right? That's a mirror. There it is. So you see, in physics, when we teach convex and concave mirrors, we show students that a curved mirror like that has a focal point and a center of curvature. What you are seeing there is you are seeing the primary ray being refocused to the focal point of the mirror. Now, in real life, the primary mirror will be more parabolic because a parabola has a fixed focal point. A convex or a concave mirror, I mean, you may have what we call a spherical aberration. And then that might actually make the focus of light not as accurate. So what you want to do is you want to play with this a little bit and maybe try to make it so light is focused like this. And I'm going to explain you why in a second. And that's just a bit too much, maybe. There. The Newtonian telescope and also the Cassegrain, they use a secondary mirror here. The secondary mirror, if you check your notes or if you go into a textbook, is a flat mirror that will be like this. It's redirecting light towards the eyepiece. And then the eyepiece will be a lens. Like that. We can even increment this, by the way. Now, sometimes I like to check what happens if I put a beam of light. And there you are. So very nice, right? Very, very nice. You basically are observing the Newtonian telescope ray diagram. Okay, see how I do my mirrors and then my lens, and then you can check with a single beam, and then you can put more rays of light, so you can actually make it look better. Now it has the option to save it. You can export it as PNG, or you can just take a screenshot, and that will be your submission. That basically will be your submission for each section of the lab. I believe when you go to the lab, you can see here, refractor, Newtonian, Curie, Cassegrain. If you go to Cassegrain telescope, it has a primary mirror, but there is a hole, there is a gap on the primary mirror because we want to use a lens, a mirror to redirect light towards there. So I will let you guys do that. You have already seen how to do 2 of the telescopes. And again, like every other lab, if you have questions, make sure you send me an email. I normally do also office hours, and I do meetups. And I'm on campus if you have any questions about not just a lecture, but also about labs. Expect another video later today about 2 labs from the solar system astronomy, which will be about the motion of the Earth and possibly the phases of Venus. Okay. All right, guys. So I'll see you guys in the next one, and have a great day.